Okay, so we're gonna use linear programming here from start to finish and go through each step. And hopefully this will help you out in being able to complete one of these all together. Okay, so Streamlined Bicycles produces two kinds of bikes, mountain bikes and road bikes. It takes 4 hours to build a mountain bike and 3 hours to build a road bike. The company has up to 840 hours available each week to assemble bikes. Due to demand, they must produce at least 250 total bikes each week. If they profit $75 on each mountain bike and $60 on each road bike, how many of each type should they produce in a week to maximize their profit? Okay, so once again, in this particular case, I'm going to start out by writing my objective function, and I know that I'm trying to maximize profit this time. So like I said, this happens a lot, but not always profit. Make sure you look to see what it is, but profit a lot of times. Okay, so it's profit here, and we know they've defined our variables for us. Mountain bikes is X, road bikes is Y. So profit $75 for each mountain bike. So 75X. And they get $60 for each road bike. So plus 60Y. So that's my objective function. Now let's take a look at our constraints. Okay, once again, when I do my constraints here, I want to remember that, ask myself, can I have negative mountain bikes or road bikes? And once again, no. So I'm going to start out by saying these two constraints to indicate I can't have negatives. Okay, don't forget those. All right, so now it says it takes 4 hours to build a mountain bike and 3 hours to build a road bike. So 4x and 3y, right? 4 hours to build a mountain bike, and they have up to 840 hours available each week. So less than or equal to 840. Okay. And then let's see, what else do we have? Due to demand, they must produce at least 250 bikes. Okay, so bikes, they don't specify mountain or road. So this means the two of them together. So X plus Y, they have to produce at least, which would be greater than or equal to 250. So now these are our constraints that we want to graph. So the X is greater than or equal to 0 and Y is greater than or equal to 0 just basically means we're in the first quadrant, which our graph already has. So that's good. So now we just need to figure out, okay, how do we graph these? And we want to use the cover-up method here. And you want to kind of figure out what your X and Y intercepts are first before you continue. Now, if you do this one right here, and you do the cover-up method, you would want to say, let's see, 840 divided by 4, you would get 210. So my x-intercept would be 210, so I'm just going to kind of write that out to see what I've got. And then you're going to do 840 divided by 3. My y-intercept would be 280. Okay. And then here on these ones, both my x and y-intercept would be 250. Okay. Now, on both the x and y-axis, I have 25 squares. Okay. So now if I did 25, I could get tens for each one of those. I could get up to 250. But I have to get up to 280, so I'm going to need a little bit bigger than that. You kind of want to keep this, use something that's as small as you possibly can to make it work. It looks like in this particular case, if I count by tens, that's not going to quite work. Now notice all of these are kind of multiples of 10. So if I do 20s, I can get in between there and be okay. So I think I'm going to count by 20s on this. And this can be kind of the tricky part, is figuring out what to count. So take your time with that. In order to do that, then I know that you don't have to label every single square. I know that 5 squares then would give me 100. So I'm just going to label, even though I'm counting by 20s, I'm just going to label every 5 squares. Okay, and we'll say that's good for there. And now I'm going to do these ones. Okay. So there we go. Again, take your time figuring that out, because the more accurate your graph is, the better and easier it is to find your answers. So really take your time and figure those parts out. Okay, so now, once again, I know I'm going to start with the bottom one first. My x-intercept would be 250. So let's see. Let's go to a different color here. 220, 240, 250 would right be in between 40 and 50. And we're going to do that same thing over here. Okay, and now I'm going to draw. Oh. A little bit tricky here. It's kind of jumping on me. All right, we're going to go something like that. Is that perfect? Not too bad. Okay. And now we said here 840 divided by 4 is going to give us 210. Okay. So let's do 210 would be right here. And then we need the y-intercept would be 840 divided by 3 is 280, what we said. So that one is right on here. Okay. Okay. So real quickly, I guess the first one I didn't shade. This purple one I would be shading in, and this red one I'm shading away. So when I look at where these overlap, it's not going to be a real large spot here. Okay, it's going to be this section in here. So I want to fill that in. And let's see how this goes. Ooh. Okay, so that's a bit better. All right, so now it's not a very big region there. So we just have to figure out what are the coordinates and vertices of those right there. Now, some of this is going to be pretty easy to tell, and some of it is going to be a little bit trickier. It looks like, so we can do the ones on the y-axis pretty easily. We know that this one right here is 250 or 0, 250. So I'm going to start with that. Okay, and then this one right here we said was 0 to 80. Okay, so now the trickier one is going to be this point right here. What is that? It appears to be 90, 160. So maybe it's 90, 160. So there's a couple different ways you can confirm that. You could take 90 and 160 and plug it into both of these and see if it is exactly equal to 840 and 250. So that's, and if it's not, then you might have to do elimination to figure out what the actual coordinates are. Or you could start out by doing elimination right away. I'm just gonna plug in and see if it works. I'm gonna do this on the second page here. So if I do 4 times 90 plus 3 times 160, if it's on the line, it should equal 840, right? So now if we do that, we get 360 plus 480, which is 840. So yeah, it's on the line, it checks out. So then the other one is a little bit easier. It's x plus y, so that would just be 90 plus 160, and that would have to equal 250, which this is 250. I guess I should have wrote that here, 840 equals 840. So it's exactly on. So yeah, 90, 160 is the point. You kind of want to make sure that that is, because it's kind of hard. You can see here, it's kind of hard to tell. You're not sure. Now, if it didn't work, then I would suggest you use elimination between these two things right here to figure out to figure out where it does cross if it didn't work out. But it looks like that's where we're at. So now I'm going to plug in to my objective function and figure out which one's going to be the best. Okay, so let's do that. Profit is equal to, let's see, 75 times 0 plus 60 times 250. Okay, I'm going to type that into your calculator, figure out what you get. If you do that, you get 15,000. In this case, that would be dollars. Okay. So next we're gonna do 75 times 0 plus 60 times 280. We know this is a little bit more. So now if you plug this in, you're gonna get 16,800 if you multiply that out. Okay, and then lastly, if we do 90 mountain bikes and 160 road bikes, okay, it's a little bit surprising here. I thought this would be a little bit more, but it's not. It looks like our best option is to just make all road bikes. And so this looks to be our best option, right? So now we want to write that and give our recommendation to them. So streamline should produce zero mountain bikes and 280 road bikes. To maximize profit. Okay, and that's how you do a linear programming problem from start to finish. Hope that makes sense.